Hi friends, welcome to today's class. So today's question is, what is determinant A if A is equal to matrix 1, 2, 3, 4? So what is the given question? You are having a matrix and you are asked to find out the determinant of the particular matrix. Here the matrix A is equal to 1, 2, 3 and 4. So det A means determinant A. You are asked to find out what is the value of determinant A. So we are having a well defined formula for the determinant. Determinant of A is equal to, what you have to do is that you have to multiply the diagonal elements. So here this forms a diagonal. So you have to multiply these diagonal elements and the second diagonal elements, and you have to take the subtraction. You have to take the difference. So determinant A is expressed like this. This is a symbol for determinant A. So determinant A is equal to det A is equal to, it is a number. You will be having a number or you will be getting a value for determinant A. So determinant A is equal to 1 into 4. So you have to do the diagonal elements multiplication. So this is one diagonal. So 1 into 4 minus 3 into 2. So you have to start from the leftmost element. That is how you can remember the formula. You have to start from the leftmost element and you have to perform the diagonal elements multiplication. That diagonal you have to multiply first minus the second diagonal. So 1 into 4 minus 3 into 2, which gives you 4 minus 6 is equal to minus 2. So minus 2 will be the value for determinant A. So this is the procedure for finding out the determinant for a particular matrix. You have to take the first diagonal minus the second diagonal. Multiply the diagonal elements of the first diagonal minus the multiplication of the second diagonal. Question number 2. Calculate the determinant of matrix 1, minus 1, 2, 3, 0, minus 4, 2, minus 3, 1. So already in the first question we saw how to calculate the determinant for a 2 cross 2 matrix. You just have to multiply the diagonal elements of the first diagonal minus the multiplication of the diagonal elements of the second diagonal. But this is a 3 cross 3 matrix. So in the case of 3 cross 3 matrix, how you can find out the determinant? So for a 2 cross 2 matrix only you will be able to find out the determinant. So what you do is that you have to omit the first row and the first column of this particular matrix. The first row and first column first you have to omit, and then you have to take the rest of the matrix. The rest of the matrix is 0, minus 4, minus 3, 1. Then you have to multiply it with this particular element. The next one, similarly you have to omit the first row and the second column of the matrix, and you have to take the remaining 4 elements, 3, minus 4, 2, 1. That particular 2 cross 2 matrix you have to consider. Then you have to multiply with minus 1. Similarly, then you have to omit the first row and third column of this particular matrix and consider the remaining 2 cross 2 matrix. Okay, I will be explaining step by step. First you can write the general formula for calculation of determinant. For a 3 cross 3 matrix, the general formula for calculation of determinant will be equal to, determinant A is equal to minus 1, sigma you have to write, sigma j is equal to 1 to n minus 1 the whole raised to j plus 1 C1j into M1j. So don't be confused by this formula. When you do this, it becomes much easier. So I'll explain it step by step. So M1j means, this you can remember, M1j means it is the matrix which is obtained by omitting row 1 and column j. So here it is written M1j. So M1j is the 2 cross 2 matrix which is obtained by omitting row 1 and column j. So j is the column which you are going to omit. So that is the meaning here. So first let us start writing the formula. First you have to omit the first column. The first column is to be omitted. So when first column is omitted, j's value is equal to 1. So first case j is equal to 1. So minus 1 the whole raised to 1 plus 1 into C1j. C1j means C11, this first element, the first column element and the first row element. It is 1 1 into M1J. M1J means it is the 2 cross 2 matrix obtained by omitting row 1 and column J. So this row is omitted plus column 1 is also omitted. So this is the 2 cross 2 matrix that is obtained. So into 0, minus 4, minus 3 and 1. So you get the first element. Now second value of J will be equal to 2. N means N will go up to the number of columns of this particular matrix. N is standing for the number of columns. So now you are going to J is equal to 2. So J is equal to 2 means it becomes minus 1 raised to 2 plus 1. J is 2 into C12. C12 means this element. You are going to omit the second column and the first row. First row is always omitted. So column only will be differing. Okay. So first you omitted first row and the first column. Second you are going to omit first row and second column. So that what is that particular element? It is minus 1. So minus 1 into what is the matrix that is obtained by the omission of the first row and second column? These 4 elements you will be getting. So 3, 2, minus 4 and 1 plus. Now your final element. Final element you will be getting like J is equal to 3. So J is equal to 3 means you will be getting minus 1 the whole raised to 3 plus 1. J is equal to 3. 3 plus 1 into you are omitting the first row and the third column. Third column and the first row you are omitting. So what is that particular element? 2. So 2 into, so first row and third column is omitted means what is the remaining 2 cross 2 matrix? You will be getting 3, 0, 2 and minus 3. So that is your final element. Now you have to add all these things. You are just solving this formula and you are adding. So what you will be getting? Minus 1 the whole raised to 1 plus 1 is equal to minus 1 the whole square which is equal to 1. So 1 plus 1 into 0 into 1 is 0. This one is normal 2 cross 2 matrix determinant. Normal 2 cross 2 matrix determinant value, that is the 0 into 1 minus 3 into minus 4 which will give you minus 12. So minus 12 plus minus 1 the whole raised to 2 plus 1, that means minus 1 the whole cube. Minus 1 the whole cube is equal to minus 1. Minus 1 into minus 1 is equal to plus 1 into, this is the determinant value for this 2 cross 2 matrix. What you will be getting? The first diagonal 3 into 1 minus 2 into minus 4. So 3 into 1 3, 3 plus 8 which gives you 11. And last one is minus 1 the whole raised to 3 plus 1, minus 1 the whole raised to 4 which gives you 1. So 1 into 2 into, and what is the value for this matrix? It will be equal to 3 into minus 3 minus 2 into 0. 2 into 0 will give you 0. So 3 into minus 3 is equal to minus 9. So minus 9 into 2 is equal to minus 18. So your final answer will be minus 12 plus 11 minus 18. So minus 1 minus 18 which gives you minus 19. So by doing more practice you will be thorough with this method and we will be solving more questions in the coming videos. Thank you for watching.